EMF in a rotating disc in a magnetic field. Rotating disc in a magnetic field. Right? So here again let me consider in this direction into the board, normally into the board. Let us consider these are the magnetic field lines going into the board, and in this magnetic field a disc is rotating. This disc is rotating and its radius be suppose L. Its radius be suppose L, and it is moving, it is rotating with angular velocity omega. Right? Now let us consider, let me use the blue ink. Let this cross represents magnetic field. Okay. Now let a disc of radius L is being rotated with angular velocity omega in a magnetic field. In a magnetic field, this P represents magnetic field as shown in the figure. As shown in the figure. Right? Now let us consider FB its frequency. FB is frequency. So that's going to be equal to if F is the frequency here, then omega, this angular velocity will be given by 2 pi F, and frequency means how many times, how many complete rotation is done in 1 second. Okay, number of rotations per unit time, you can say that. So F means number of rotations per second, you can consider it. Now here you see area of the disc. So area of the disc is here pi L square. Instead of R we are taking radius L, isn't it? So this area of the disc will be the area covered in one rotation. So you can say area covered in one rotation. Area covered in one rotation. Now from here you can see, so area of the disc, let me represent this by capital A. Capital A is equal to pi L square, suppose. Okay. Let me represent the area by capital A. Now here this area capital A is the area covered in one rotation, and F represents number of rotations per unit second. Then area covered in 1 second, area covered per unit second will be the rate of change of area, you can say. So area covered per unit second, you can say that is dA by dt, rate of change of area. That's going to be in one rotation. A is the area and F is the number of rotations per unit second. Then that's going to be equal to A into F. A into F, right? That's going to be equal to A into F. dA dt is F. Now what will be the flux? So this disc is rotating in this way, right? In this way, in this direction, and magnetic field lines are going in this way normally to the board, right? Then flux phi, magnetic flux, is given by B vector dot A vector, and dot product of these two vectors will be B A cos theta according to vector dot product. Here B is magnetic field. We know this B is nothing but magnetic field, and vector A is area vector. This is area vector. So here you see, if this is the disc, and then its area vector should be in the same direction with the magnetic field. Then if vector A and vector B are in same direction, therefore angle between vector B and vector A is theta is equal to 0 degree, and cos 0 degree we know that is 1. So cos theta will be 1 in this case. Therefore we can write phi is equal to BA. So we have got phi is equal to BA. Now here you see, induced EMF E is equal to, you know, minus d phi by dt, and minus comes from Lenz's law, isn't it? So that's why we can write d by dt of phi is nothing but BA. So let's put BA here, BA, and B is constant because B is uniform. This is uniform magnetic field. This is uniform magnetic field. Uniform magnetic field. So here you see, we can write minus B dA by dt, right? And here dA by dt is nothing but A. We can write it implies E minus B A F. So dA by dt is AF. So now from this relation we can write F is equal to, from this relation we can write F is equal to 2 pi, sorry, not 2 pi, omega by 2 pi, omega by 2 pi, and A is pi L square. So let us replace this A and F by these two values, this one A and F. So let us replace this. Then what you will get? Then you will get E is equal to minus B. A is pi L square, and F is omega 2 pi. Then here you see this pi cancel. So our final result is E minus half B L square omega. So this is our final result. So hope you have understood this. So this is the required expression. So again I am telling you, this minus sign, you don't have to use this minus sign when you will solve numerical problems, when you will calculate magnitude of EMF. This minus sign represents the it comes from Lenz's law, because Lenz's law says that the region for which EMF is produced, EMF opposes that region. So as it opposes the region of its product, that's why this minus sign comes, right? So this is all about EMF in rotating, EMF in a rotating disc in a magnetic feet. So hope you have understood.